2, 2, 2. How many times can you see the number 2?
3 times.
3 times. So the power is 3. So you write this down as 2 to the power of 3. The little 3 at the top there. This tells you how many times you see the 2 in the times in the product here. And there's some names that we use in English. This is this number here. It's called the base number. The big number is the base number. And the little number we call the index or the power. Okay? You see that?
Yeah.
Look, what I'll do, I'll show you some things to do with this, and then you can tell me how I could write it down in a more straightforward way. You ready?
Yeah.
Okay. Yeah. So if I wrote this down now, if I had something like let's see, if I had 2 to the power of 4 times by 2 to the power of 3, you see that this one will be 2, 2, 2, 2.
Yeah.
And this one will be 2, 2, 2. So if I write that out in full, this one, 2 times 2 times 2 times 2 is this one, times 2 times 2 times. Okay with that?
Yeah.
How many times can you now see the 2?
7 times.
7 times. So see, you see that okay?
Yep.
Can you hear me okay?
Yep.
So look, so this is going to be 2, 2, 2, 2, 2, 2, 2. And now see it 7 times. So I'll write this now as 2 power of 7. Okay?
Yeah.
So this would then be equal to, well, hang on. How could I get to the number 7 if I have the number 4 and the number 3 here?
Add.
Do that.
Add.
Add the powers. Okay?
Yep.
Okay. So if I were to do this, Nathan, you see the base number? If I choose that to be any number, and I have it to a power, say, of p, any number to any power, and I then times that by this, I need the same number here, the same base number, to the power of, say, a different number. So you see I've got 2 to the power 4, 2 to the power 4, times by 2 to the power of 3, the different numbers. Same base number here. Could you tell me how I could write this out, possibly, using this information? See, it's 2 to the power 7, 2 to the power 4 plus 3. So here it would be
A to power P plus.
Yeah, that's it. P plus Q, yeah. Just like that. And in England, we call this a law. You have to do it in law. It's index law number 1.
Okay.
Yeah.
And in a sentence, when you have the same base number and you're multiplying, add the powers. Always the same. So if I do this one now, if I did 4 to the power of 5 times by 4 to the power of 6, what would that be? Same as 4 to the power of
11.
perfect. That is a very large number. 4 times 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 4.
Yeah.
A massive, massive number. Huge.
Yeah.
But these numbers, when you see them like this, when it's just the number 2 to the power of 3, 2 times 2 is
4.
times 2 is 8.
8.
So that there is the number 8. Another way to write it down. Same value with a different look. That's 8. 2 to the power 7. 2 times 2
4.
times 2
8.
times 2
16.
times 2
32.
times 2,
46.
64.
4.
Yeah, times 2,
8.
8.
128.
Yes. So look, can you see that 2 to the power 7 doesn't look very big, does it?
No.
Numbers we're writing down, but it's a big number, 128. Okay, that makes sense?
Yeah.
So this one here, Nato, is law number 1. It's the multiplication law. You add the powers. Okay? Okay with that? What about this one? Ready? You know the symbol?
Divide.
Divide. So if I now do this one for you. So this is similar to what you have on your question there, yeah?
Yeah.
Now, what does this mean? Can you say what that is?
It's 3 to the power of 4.
So try and say it like this. 3, 3, 3, 3.
Yeah.
Your turn.
3, 3, 3, 3.
Divided by
3, 3.
Yeah. Can you see in this fraction that you've now got the number 3 here and the number 3 here? So because they're in the same number, they're called common factors. And in England, you can cancel that down because 3/3 is the same as 1. Okay? So I can do this. I can cancel that down. Cancel that one down with this one. 3/3. Oh, look, there's another one here. That's also common with that one. You see, okay?
No.
So this would then be the same as 3 times 3 over 1 times 1. So this is equal to 3, 3. Okay?
Yeah.
Look, you can cancel down the common factors, is the language here in England for this.
Hoe is dat bij ons?
Ja, dat weet ik.
Ik weet dat ook niet.
Okay.
Ja.
What about this one? What about
It's 8, 8, 8, 8, 8, 8, 8, 8, 8.
Brilliant. Huge number.
Yeah.
Times 8 times 8 times 8. Massive number.
Yeah.
Can you see any common factors?
8.
This one with that one. Can you see any more?
8
This one with this one. Can
and
you
8.
see more? What's that, Seamus? Eight, 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 eight.
Yeah.
Yeah. Okay. You ready then? What if I had this? What now?
Is dat bovenste een 9 of een 4?
Ja. Ik kan dat scherm niet groter maken.
So you've got 8 to the power of 9 divided by 8 to the power of 3. Is it 8 to the power of 6? 8 to the power of 9 divided by 8 to the power of 3 gives you 8 to the power of 6. How do you get 6 from the 9 and the 3?
You wacht even, subtract.
Yes. And what we can do with this, you know the symbol here? Something compared to something. Something compared to something. We could rewrite that like this, Nathan. We could go. Yes, okay. I've got it. You see this okay?
Yeah.
See, it's the same value but a different look. Will equal same as this. You okay?
Yeah.
Yeah? And that's number 2. Okay?
Yeah.
Is this what you've done in class already?
What?
Have you seen this in your classroom with your teacher?
Yeah.
Exactly the same?
Not exactly the same, but sort of.
So maybe you see this
Yeah.
and maybe you just see this. You just told what it is.
Yeah.
You have the explanation. Maybe. Yeah? Let me see if you know this one as well. What's this? What if I did
Wat is nu weer normaal?
Multiply.
It's 3 times 2.
there's not a 3 times. You see it 3 times. 2, 2, 2.
Yeah.
But what does this say?
2.
That is times by itself. So watch. This is the same as
Mhm.
I have this and again. I have this and again. Okay?
Yeah.
What would this be? 2 to the power of,
That's
add these now.
9.
Go back to number 1.
Dat is natuurlijk 3, hè?
Dan niet doen.
We add 6.
Yes. So that will see, I've written this out like number 1. Okay?
Yeah.
But this.
Five times. No.
5 power 4
5 power 4 times 5
power
power
4
4. Yeah.
times 5 to the power 4
Wat, hè?
Times 5 power 4
times,
5 power 4 times 5 power 4.
and now if you add them all together, 4, add 4, add 4, power of
20, power of 20.
yes, huge number.
Mhm.
5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, massive number. But look how it's written.
Yeah.
Very neat and tidy, but it's a massive number. Okay, what's this?
Dat is een manier om grote cijfers klein te schrijven.
Ja, wij gebruiken de wetenschappelijke termen. Dat is nog anders.
Ja.
Three of 3, and then all to the power of 2 gets me to the power of 6. Power of 4, and then the power of 5, power of a power, gets to the power of 20. How?
Add.
Think. 4 add 5 is
Not 9.
9.
It's 20. Nu snap ik het niet meer.
Begin van
3 add 2 would be 5, wouldn't it?
Yeah.
So how? How do I get to 20 from 4 and 5?
5 times power 4.
See? Okay? Yeah. Number 3.
Je moet even op een grote scherm zetten. Bepalen.
Ja.
Of beter. Maar kijk op het scherm. Ja.
Okay?
Ja.
I'll show you one more. Okay?
Ja.
More for you.
It's subtract, I think. And then 0. And it's 1.
Yeah, watch. Yeah, watch. This could also be 5, 5 compared to 5, 5 Can you see any common factors here?
5 and 5
Cancel that one down, yes?
and 5.
Cancel that one down. 1 compared to 1 is 1.
Tot een 0 is allemaal 1.
You know this, yeah?
Ja,
So look, if 5 to the power of 2 divided by 5 to the power of 2 is equal to 1, and if 5 to the power of 2 divided by 5 to the power of 2 is 5 to the power of 0, if this equals this, and if this equals that, then
ja.
okay, so we can now do this, Nathan. No, anything to the power of 0,
Altijd 1.
value of 1,
Ja,
and that will be, for now, that will be number 4. Okay,
ja.
show me your questions again. Let's do a few questions.
Ja.
Show me some questions you have to do.
We have to do like this. If it wait, those.
Oh, you have negative powers as well. Okay, that's fine. I'll give you one more then. Ready? I'll give you one more because of what you have there. What if I had this?
I'm gonna leave it. Okay.
Can you see that okay?
Yeah.
3 to the power 5 divided by 3 to the power 7.
Yeah.
What do you do with the powers?
You subtract.
Good lad, well done. Yes, perfect.
They have
3 to the
minus
power,
-2.
well, I would say, you're not wrong, but I would say -2.
Yeah.
Okay. Hang on, watch. 3, 3, 3, 3, 3. Divided by 3, 3, 3, 3, 3, 3, 3.
Yeah.
Unique common factors.
3,
This one,
3, 3, 3,
this
3,
one,
3,
this one,
3 and 3.
this one. Oh, look. Yeah.
Yeah.
So look, 3 to the power of -2 is the same as 1 over 3 to the power of 2. So what that means, Nathan, is that we've got anything to a negative power will be equal to 1 over anything to the power.
Kliek van de. Ja.
Okay, and we'll call that one number 5. Okay.
Ja.
Now show me the questions again.
This or other?
Pull it back just a fraction. There,
There it is, yeah.
so it's x to the power 4
Take away.
times
Times x minus 4.
x to the power of negative 2.
You have to pull it back.
Put it back a little bit, Naton.
Go back. There. Good.
Right,
Perfect.
times x to the power of 3. Yes?
Yeah.
Divided by x times x to the power of negative 3 times x to the power of
Pull it back.
3,
Go back. 5.
5. Okay. Ready then?
Yeah.
Can you see? Same base number. All x's.
Yeah.
X, same base number. Okay? So what do I do with the powers? When I'm timesing them, I add them. 4
Add
add
the-
negative 2.
Add the power.
Yeah, add the powers, yeah. 4 add negative 2.
Power 2.
And then to power 3, add 3.
Power 5.
Good. Compare to. You see here, see this one?
Yeah.
It's not written in, but it's actually x to the power of 1. It's just there once, isn't it? It's to the
Yeah.
power of 1.
Yeah.
Power of negative 3. So now add the powers. Because you're timesing. Can you see this? You're timesing. So 1 add negative 3. Then add 5. How many is that?
Power 3.
Good. Now, is this divided by this? Do what now? Number 2?
Power 2.
Yeah, no. Well, yes, it is because you subtract. Yes.
Yeah.
So here, get from here to here is number 1. To get from here to here is number 1. Add the powers. And then to get from here to here is number 2. Because you're dividing now. Here you're dividing, so subtract the powers. Did you get that on your question before? X to the power 2?
Yeah.
Woohoo! Good. Show me one that you're not sure about. Good. Good stuff, Nathan. Well done.
Even
Chris?
this one. Like this one.
Negative 2 to the power of negative 1.
Yeah.
Yeah. Okay, hang on. So, and then times by negative 2 to the power of 3. Yeah?
Yeah.
Okay, like this.
Yeah.
Nathan, look. Look at these numbers here. You see they're the same number here. They're the same base number.
Yeah.
It's the same? So it's the same. You're timesing. What do you do to powers? Number 1, what do you do?
Add.
So it's the same base number. What power? Negative 1 add 3?
Power 2.
Perfect. Now, that means times by itself. So this would then be the same as negative 2 times negative 2. What's that value? Times negative 2. 4.
Yeah.
Okay. Show me the next tricky one. See, Nathan, it's the same, but look, these numbers here, the base numbers are the same, aren't they?
Yeah.
You see here, negative 2 and negative 2, they're the same. So you've got the same base number. That's like your A, in your rules. Okay?
Yeah.
Show me another one.
Yeah, this one. Come on. Wait.
Number 7.
Yeah. No, 8.
Number 8. Well, you know it. You know.
Yeah.
What is that one?
7.
Number 7.
Yeah.
Is it 6 to the power of, come back a little bit. Over 6 to the power of 3, is it?
Yeah, it's 2 power 3.
6 to the power of 3 divided by 6 to the power of 3.
5. Power 5.
Sorry, okay, so this one. You're dividing. What do you do with the powers?
Subtract.
Okay, 3 take away 5.
2.
Try again.
3 take away -2.
Ta-da. It's the same.
Yeah.
It's the same. There's no difference. This is the same base number, isn't it?
Yeah.
You're dividing, aren't you? You subtract the powers.
Yeah.
So that's number 2, isn't it? Rule number 2. Okay, show me another one.
Okay. Six.
Number 6. Negative AB squared. Okay, got it? The power of,
-2.
oh, it's all right, over, hang on. 3 A squared B to the -2.
Yeah.
Okay?
Yeah.
Ready? Is that right, Nathan? Have we got that correct?
Yeah.
So, see the negative power?
Yeah.
What does that mean?
Subtract.
Number 4. Or is it number 5? The negative power means 1 over. Okay?
Yeah.
But hang on, look inside here. I'm going to look inside there first, Nathan. Look. Can you see?
Yeah.
I'm going to look carefully and see what's there. I can see inside there this. Negative A, B, B. Negative A, B, B. And then
Yeah.
the denominator, 3 A, B. A, B. Can you hear it?
Yeah.
Now look inside there now, right now, before we do anything else. Can you see any common factors in here now?
A.
A,
1B.
yeah.
Yeah.
So now what you've got is, I'll do it over here, okay? Negative B over 3A. The power of -2. Okay? Do you see that okay?
Yeah.
But hey, hang on, look. The negative power means what? One thing only. 1 over.
1 over, yeah. Yeah.
So this is the negative power here, yes? 1 over. Okay?
Yeah.
This means 1 over negative b over 3a times by negative b over 3a. See it?
Yeah.
It's squared now. It's times by itself. Okay? Negative b times negative b. B squared, yes?
Yeah.
Over 3a times 3a. 9a. Okay, you see that okay?
Yeah.
Okay. Now, when you have 1 over this fraction here, it's to teach you back for some division to show you this next thing more carefully. Maybe you don't have time now to do it. But what happens with this is that when you have 1 over this fraction, it's the same as that being that inverted. When you have 1 over that fraction. I teach you the division so you can see it?
Yeah.
Okay, look. We'll come back to this in a moment, okay?
Yep.
Look, if I have 1 divided by a half, like this, when we did the division means group, doesn't it?
Yeah.
How many groups of a half can you see in 1? Well, right now you can't see any.
No.
If I rewrite my number 1 as halves, that's 2 halves, isn't it?
Yeah.
So this is the same as 2 halves divided by 1 half. How many groups of 1 half can you see in 2 halves?
2.
So 1 divided by a half is 2. Okay?
Yeah.
What if I had this? What if I had 1 divided by 2/3? I want to know about groups of 2/3. How many in 1? I can't see any thirds, can I?
No.
So rewrite the number 1 as thirds. 3/3 is 1
Yeah.
divided by 2/3. Can you see that you have a pile of 3/3, but you want a pile of 2/3?
Yeah.
It will be 3 compared to 2.
Yeah.
Look, this is this fraction. The answer here is this fraction inverted on the result of the division. I'm just showing you some number examples there for it. Okay?
Yeah.
Now look here. This is 1 over this fraction. 1 over that fraction gave me 3 halves. 1 over this fraction will give me
Yeah.
That's a tricky step. I'm not going to say that's straightforward to do that. But this is the example as to why it works like that, Nathan.
Yeah.
And we may need to do some more work with dividing fractions before we come to something, because this is, I'll be honest, this is quite complex.
Yeah, it is.
If you can see it, do it.
Yeah.
You want to show me another one?
Yeah. Um, like here. There's I had one, but I lost it.
Okay, well, don't panic.
I lost it. Where is it? Here. Like this one
Number
here, and then with this.
number
With this-
11.
Yeah. Like 2 here and then the power here.
Okay, c to the power of 4, yeah? Times by c to the power of negative
-5.
c to the power of 4. C to the power of 4 times by c to the power of -5. All of that to the power of -1, yes?
This, yeah.
Yep, perfect, okay? Look inside the bracket. Look inside the bracket. Something times something. What do you do with the powers when you're timesing?
Add.
Yeah. 4 add -5. To the power of -1.
Yeah.
Okay? What does this mean? What does the negative power mean? 1 over.
1 over. Yeah.
So this would be the same as 1 over c -1. Okay? We're just inside the bracket, yeah? Inside, inside, inside. Just look inside for now. Okay?
Yeah.
Look here. What does this mean?
-1.
He says -1, -1. What does it mean?
1 over.
Yeah, 1 over. Okay?
Yeah.
And then what do you do with this?
You turn it around.
Okay, it'd be like c over 1, wouldn't it?
Yeah.
Which is the same as c.
Yeah.
Okay?
Yeah.
Next one. Nathan, you see the symbol here?
Yeah.
When we do this, same value, different look.
Yeah.
Yeah. You could put equals there probably at school.
Yeah.
Okay. Okay, next.
Also,
That's okay.
like wait, no, it's here. With the tens.
Okay. 10 to the power of -2 divided by 10. Yes?
Yeah.
Yeah, -2.
Okay, ready?
Yeah.
It's not written in. The power's not written here. How many times can you see the 10? Once.
1.
So it's 10 to the power of 1.
Yeah.
It's not written in, so you have to know. It's 10 to the power of 1. Oh, you're dividing. What do you do with the powers?
Subtract.
Subtract. -2 minus 1.
Yeah.
-3. Can you see?
Yeah.
It's not written in, so write it in. Write in the power 1 when it's not there.
Yeah.
Because then you can see it. If you can see it, you then know when you're dividing, subtract the powers. -2 minus 1, -3.
Yeah.
That's it. Okay?
Yeah. And then here.
Number 5.
Yeah, 6.
Number 6. Okay? -2.5 to the power of 2
Yeah.
divided by -2.5 power of 3.
Yeah.
Okay?
Yeah.
Is it the same base number? Is this the
yeah.
same number?
Yeah.
Same base. What do you do with the powers? You're dividing. What do you do?
Subtract.
Subtract. What's 2 minus 3?
Minus 1.
-1. What does that? Negative power, what does it mean? 1 over.
1 over, yeah. 1 over 2 point. 1 over 2.5.
Yes. Okay. Do you know 2.5 is 5 halves?
Yeah.
You know that? So that's the same as 1 over 5 halves.
Yeah.
What do you do with this?
You turn it around.
So that would then be
5 over 1.
it's 1 divided by 5 halves. Okay, ready?
Yeah.
Divided by 5 halves. See any halves in the 1?
No.
So write that as halves. 2 halves divided by 5 halves. Okay?
Yeah.
How many groups of 5 halves can you see in 2 halves?
Yeah.
You got a pile of 2, but you wanted a pile of 5, didn't you? A group of 5.
Yeah.
It's 2/5.
Yeah.
Okay?
Yeah.
Should you do one more?
Yeah.
Number 10.
Well, he's lost his sound, so I have to unmute himself. Or if you unmute him.
Yeah.
Number 10, yeah?
Yep.
Okay. So is negative a cubed b
Yeah.
over 2ab, and that is all squared, yes?
Yep.
But Nathan, I want you to tell me what to do with this one, and I want you to concentrate on the inside first. Can you see any common factors on the inside?
A.
Yeah. That a there will cancel with one of these, won't it?
Yeah.
It'll be a squared there now, won't it? Yes?
Yeah.
A. Not a anymore, but just a.
Yeah.
And what about anything else?
B.
So what does that now simplify to? This will be like, still going to square it. It'd be negative AA compared to 2.
Yeah.
Do you see that okay?
Yeah.
Okay, so with these, work inside the brackets first. Now what does this mean?
Square.
Yeah, so negative a squared over 2 times by negative a squared over 2. AA times AA,
Yeah.
and they're both negative, so it'll be positive, yes? Negative times negative. A.
Yeah. A4.
8 to the power 4, yeah? And then 2 times 2.
4.
Okay? So you'll need to practice and practice and practice the other examples like those.
Yeah.
And if you need any more help with that, just message Heidi with it.
Yeah.
That make a bit more sense for you now.
Yeah.
Okay. Now there are a few rules, but we've done 4 or 5, did we? Timesing to add the powers. Dividing, subtract the powers.
Yeah.
Power 0 is 1.
1.
Power of the power, we times the powers.
Once, yeah.
Yeah. And then the negative power means,
1 over.
so we did 5 of the rules.
Yeah.
Enough for you?
Yeah.
Coolio. Good.
Naton, do you want to do the session again on this? Another time? Do you want to do it again? Because it's the practice hearing it again and again that will help. Do you want to do another session or do something different another time?
We can do it again.
Good. Because each time he does it. Now, I will put this on the Facebook page so you can look back, but we can do another session.
Yeah, whatever you need, Nathan. Yeah.
What's better for you, Sundays or Wednesdays? Or is it best to stick to Wednesdays?
Wednesdays.
Wednesdays. Can you do another one next Wednesday?
I think so, yeah.
Yeah? Okay. If you can't just get Dad or you message me and we'll organise a time. But Wednesday, 7 o'clock? What time is it there? Is it 8?
Now it's almost 9.
9.
Oh,
yeah.
okay. So you're 1 hour ahead.
Yeah.
Okay. So we will see you again next Wednesday. More of this. And if there's anything else you want to do, we'll just keep... Naton, when is your exam?
In 2 weeks.
Okay.
Well, you have other topics as well you want to look at, Nathan. We can do that as well, okay? So we'll do a recap of this. Do the practice now and try your best to follow the video and then do the practice each time.
Yeah.
And learn those rules. Write them down for you now. Finish off.
That'd be a good idea.
Yeah?
Yeah. So in one place so you can see them.
Okay.
And Naton copies them down.
Yeah. Are you ready, Nathan?
Yeah.
So there's 5 rules, yeah, we just did. There's more than 5, but I'm just doing the 5 with you now, yeah?
Yeah.
So if the base number is the same and you're timesing, add the powers. Is number 1, okay?
Yeah.
Now, maybe for the second one that's on, that you may see like this, or like this. So it could be that you're dividing like this, or you're dividing like this, yes?
Yeah.
Whichever way around you see it. You remember for this one? You're dividing, you're going to subtract the powers, yes?
Yeah.
That would be number 2.
Yeah.
Then we did this one. Remember what we did for this one? We've not done practice like this one though, in your examples there. What will we do now with the P and the Q?
Multiply.
Multiply. Brilliant, well done. That was number 3. We then did this one. Anything to the power of 0. You remember?
Yeah.
As a value of 1.
Yeah.
And then the last one we did when you have a negative power, the negative bit means one thing and one thing only. It means
1 over.
1 over. See, the negative means 1 over, one thing and one thing only. Okay?
Yep.
That's number 5.
Yeah.
Okay? And then remember when you get the ones inside the brackets where they look a little bit complex as fractions, look for common factors. Tidy that up first and then
Yeah.
these things. Okay? Boat down the river, don't paddle hard.
Yeah.
Make life a little bit more straightforward for yourself, okay?
Yeah.
Good job. Nice one. Any
Yeah.
questions from Dad? Is he gone?
Nope. It's all clear.
Great stuff. Okay, Nathan, we'll see you next Wednesday then, yeah?
Yeah. Bye.
Good luck with your practice.